Welcome to Complexity Made Simple, and my name is Paul Allen. And before we get into today's fantastic video newsletter, what I'd like to talk to you about is all the materials that you can purchase to help to support the channel. We've got these fantastic textbooks that range from the simple statistical process control for small batch production. We've got the 7 quality tools for world-class problem solving, which is essentially yellow belt material. Then we move on to design of experiments for 21st century engineers. Every engineer and scientist needs to be able to do design of experiments. And then finally, drink tea and read the paper. The most fantastic green belt handbook you can buy on the market today, full of practical tips and fantastic physics that'll help you become a world-class engineer and a world-class quality engineer. Of course, you can also click on the link to buy me a coffee and make a donation. That would be fantastic. But at the very least, click on subscribe, click on like the video, because it all helps to support the channel. Many thanks for your help, and now on to today's video. Welcome to the latest video. And in this video newsletter, what we're going to be talking about is the power of the run chart to demonstrate process control. Okay, so this is the simplest tool, the simplest statistical tool that you could ever pull out of the box. The power of the run chart. And I wish I could get people to plot a goddamn graph. All we're talking about is this type of simple graph. And it's such a powerful diagram, but I can't get people to do this particular technique if they collect data. If you collect any data at all, avoid the Excel spreadsheet and turn it into an Excel run chart. Now, in order to make my point, I'm going to use a little case study. I'm not going to talk to you about the actual improvements that the project has gone through, but I'm just going to show you the power of plotting a graph effectively. And really what we're going to talk about, process behavior. Because process behavior equals process control. It's a much better phrase to use, process behavior, because that's really what control means. If your process behavior changes, the process control has changed. Therefore, you're out of your current control and you should investigate. You should do something about it. Process behavior rings loud and clear on a run chart. So let's take a look at some run charts that I was presented about a week ago in a certification event, and it just struck me when I saw them. Oh, beautiful. This is a run chart doing its job in spades. Let's take a look at what was presented. Okay, so here are the run charts that I was presented. Now really what these run charts are showing you is the sort of justification for the project and the history of the project, in a way, the result of the project that was conducted. And the process is it's a filter test in a laboratory, so it's a quality test for a particular product. And of course, if you're doing measurements, you need your measurements to be under control, because if your measurement system isn't under control, you're going to get yourself a problem. Now, in this particular case, we are dealing with something called filter time. So you can see different levels of filter time. Then they work out something at the end called the filter index. But the two graphs that are most important are the 10 mil filter time, the 50 mil filter time. And here's the graphs that were presented. Now, it struck me when I saw this that if these graphs had been drawn every day as each test was done, there is a possibility that we would never have arrived at this project. This project would never have happened if a graph had been drawn. So let's take a look at the first graph, the 10mm filter time. Now what we've got, look, is a graph of the 2018 performance of this process. That's the blue line that you can see, and it's a really consistent process. So the filter time is around about 45 seconds on average, and it's sitting between about 42 seconds and 48 seconds. That's its natural process behavior. The blue line was the original process behavior. Now, the minute you see the graph of the 2023 process behavior, which is the orange line, you immediately go, what the hell has gone on with this process? Now, don't get me wrong, the process is still maintaining a similar average. It's around about 45 seconds, but look at the state of it. It's all over the place. Now, that is a change in process behavior. That is a change in process behavior. What does that mean? It means your process is out of control. Something changed. Now that is only possible to see on a run chart. Now if these run charts were plotted, I can't believe that they would have allowed the blue line to turn into the orange line if they'd have been plotting the graph. They would have investigated the process changes long before this process deteriorated so badly. But this process deteriorated so badly for the want of the simplest, cheapest tool you could ever use, a run chart. It's clear and plain and just so obvious in the different elements of process behavior. Now, of course, ultimately someone's done a project on this and they've done two things. They've got the process back under similar control, which is now the grey line, but they've also done something really good, which is dropped the filter time as well. So the process now is back under process control. Its behavior is very similar, but it's also controlled and improved because it's quicker, as this one is as well. The 50mm filter time is exactly the same. But for me, when I saw this, I thought, this process, this project only happened because nobody could be bothered to plot a graph. Now, this is a very short video because this is an easy point to make. The power of the run chart. The power of the run chart. When you've got a process and it has a particular behavior, all you have to do is plot the goddamn graph. This is free money. You've collected the data points. You have the numbers, but you just can't be bothered to plot the graph. It's free money. And if the process moves on and starts to deteriorate, you're going to see this really quickly. You are never going to see that in a table of numbers. You're never going to see your true process behavior Now, of course, what ultimately these diagrams get turned into is ultimately you can calculate limits and you can turn this into a process control chart. Of course you can do that. That's more technical. Needs a bit more skill, bit more understanding. You're going to have to do more training with people if you turn it into a process control chart. But my God, just plot the graph, because process control equals consistent process behavior. It doesn't mean defect free. It means you're maintaining the conditions every single day that make your process behave in a particular way. And if you do that, the process is under control. You are maintaining consistent conditions to create consistent process behavior. And that's all process control means. And by the way, the best companies in the world are brilliant at maintaining process behavior. They are brilliant at maintaining consistent process conditions. Plot the graph every time you collect numbers. Plot the graph and then get a brilliant system for maintaining process conditions, and you will definitely become world class and smash your competition to pieces. And that's what we want you to do.